Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारी एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोस गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोस गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोस रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू बढ़े मध्ये करिवो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े पारिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रु तमे क्लिक करी डाउनलोड मध्ये करि पारिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि पारिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें लाइन सरफेस एंड वॉल्यूम इंटीग्रल्स ऑफ वेक्टर फील्ड्स ए विषय रे पढिबा सो फर्स्ट लाइन इंटीग्रल so actually the integral of a point function along a curve is called your line integral and for this let us say vector r which is a function of t remember एठी r bold हेची माने this is a vector okay so तमे लेखिला बेलकू r ऊपरे एरो मार्क लिखिबो okay now suppose it is the equation of a curve and now if phi and a are scalar and vector fields respectively and dr is the vector increment of the length then we can have the following three integrals integration over c phi dr integration over c a dot dr then integration over c a cross dr okay each of which being known as the line integral along the curve okay and this curve may be open or closed okay now the results of the integrations are respectively a vector okay phi dr will give you a vector a dot dr will give you a scalar and a cross dr will give you a vector okay now to compute any of these integrals actually we have to do one method we have to reduce the vector integrals into scalar integrals with which one is assumed to be familiar right now as phi is a scalar function and dr can be written as I dx plus j dy plus k dz so above equation 1 can be reduced to this form okay involving the x y and z integral right now the three integrals on the RHS of the above equation are actually ordinary scalar integrals and to avoid complications we shall assume that they are Riemann integrals okay so the integrals with respect to x cannot be evaluated unless we know the value of y and z in terms of x similarly the same argument holds for the integrals with respect to y and z also right so this simply means that the path of the integration that is c must be specified unless the integrand has special properties that lead the integral to depend only on the value of the endpoints right and the value of the integral will depend upon the particular choice of c right now the line integral of equation 2 and 3 may be interpreted in the similar fashion and like that of your integral 1 they are dependent and in general on the choice of the path okay line integral 2 is most commonly used in vector analysis that is a dot dr and it is called line integral of the tangential component of vector a along the curve c okay an important example of line integral of the vector function is the work done by a force so jodi f hegola tomoro force which is acting on the particle then the line integral that is f dot dr will represent the work done by the force right an important special case which arises in the scalar calculus when the function to be integrated is an exact differential where the value of integral is independent upon the path and in vector analysis suppose a is equal to gradient of phi that is del phi then we can have suppose the limits are from p to q of a dot dr. Okay, then this is del phi dot dr, putting the value of del phi and dr. Okay, this will be the dot product. Okay, I dot I, j dot j और k dot k रही term गुड़ा एठी रहिला, right? And this is simply integration from p to q of d phi, which is phi q minus phi p. Okay, here we have taken p and q to be the initial and final points of the curve having coordinates, suppose x1 y1 z1 and x2 y2 z2. Okay, now if the integration is taken around a closed curve, then in that case q will be equal to p, and here the integration will be a closed integral or a cyclic integral, right? And this symbol is actually denotes the integral along the boundary of the closed curve, right? And it is equal to now 0 because phi p minus phi p is which is 0, right? Thus if a is equal to the gradient of phi, then the integral of a dot dr depends only on the initial and final values of phi, and it is independent upon the path. And also if we take the closed curve, then for cyclic integral taken over a dot dr will be equal to 0. Okay, now conversely, if the cyclic integral taken over a dot dr is equal to 0, then there must exist a scalar point function, that is phi, such that a is equal to gradient of phi, right? Now if the line integral, that is integration over c a dot dr, is independent upon the path, then the vector field A is said to be a conservative or non-curl vector field. And from the above discussion, we can say that a vector field A is said to be conservative if and only if there exists a scalar point function phi such that A is equal to gradient of phi. And conversely, if a vector field A is derivable from a scalar point function phi according to the relation A equal to grad phi, then the vector field A is actually conservative field, right? Acha. Now let us see the second one, which is the surface integral. So for this, let us say capital S to be any surface which is divided into small infinitesimal elements, each of which may be considered as vector ds. Okay, so again এটা bold ହେଇଛି s ମାନେ এটা তুমি ଲେଖିଲା ବେଳକୁ ୟା ଉପରେ vector symbol ଦବ, right? So if phi and a are again scalar and vector fields respectively, then the surface integrals again we can have three types, which is first one है phi ds. Okay, double integral एठी पड़ी तापरे a dot ds, then a cross ds. Okay, एठी मने रखो आउ थरे कहूची ds ऊपर सब एरो मार्क लागिबो, a ऊपर मध्य एरो मार्क लागिबो, right? So the results of the integrations are respectively, first one will give you a vector, second one will give you a scalar, and the third one will give you a vector. Okay, now often the area element ds, actually it can be written as vector ds which is equal to n cap ds. Okay, here ds is magnitude and n cap is the unit normal vector to indicate the positive direction. Okay, now here one thing you remember, suppose this is the surface area element ds, then the surface area vector will be normal or perpendicular to this element, this is ds vector, which is equal to n cap ds, right? And there are two conventions for choosing the positive direction. The first one is if the surface is closed surface, then we agree to take the outward normal as positive. Now second one, if the surface is an open surface, then the positive normal depends on the direction in which the perimeter of the open surface is traversed. And for this, if the right hand fingers are placed in the direction of travel around the perimeter, then the positive normal will be indicated by the thumb of the right hand. Okay, just like that of your right hand curl rule, right? Acha. Now the surface integral of a dot ds is called the flow of flux of the vector function a through the given surface S. Suppose for example, if a is the product of rho and v such that rho is the density and v is the velocity of the fluid, Then the surface integral of rho v dot ds will denote the amount of fluid flowing through the given surface in unit time. Right. Now in the third case we have the volume integral, and for this let us say dv is equal to the product of dx, dy and dz, and it denotes the element of volume or the volume element, which is a scalar quantity. Okay, so that there will be only two possible volume integrals, that is the triple integral of phi dv and a dv. Okay, and the results of these two integrations are respectively a scalar and a vector. Okay, the first one will give you a scalar and the second one will give you a vector. Now it is often convenient to convert the multiple integrals into others having fewer integral signs, right? And this is done by two important theorems, that is your Gauss divergence theorem and Stokes theorem, okay, of your vector analysis. So এই দুইটা theorem আমি আকু পড়িবা. Now let us solve some of the problems related to your line, surface and volume integrals. The first one, it is saying that find the work done in moving a particle in the force field, and the force is given as a vector like this, and it is along the curve which is defined by x square equal to 4y, 3x square equal to 8z and x equal to 0 to x equal to 2 are the limits. Okay, so we know that the work is equal to the line integral of f dot dr. ताले अबे हमें f आउ dr रो वैल्यू इजीली याको पुट कर दबा. Okay, and we take the dot product. This will be like this. Now defining the equation of curve, that is given in the equation, that is x square equal to 4y and 3x square equal to 8z. Now we can differentiate so that 2x dx will be equal to 4 dy, 6x dx will be 8 dz, and this equation will give you y equal to x square by 4 and z equal to 3x square by 8. So we have got y and z value in terms of x, right? Similarly dy will be x dx by 2 and dz will be 3 by 4 of x dx. So we substitute these values in equation 1 and solve for the final result, which is coming out to be equal to 249 by 40. Okay, so तुम टिके चेक करिवो जदि बाय चांस किछि भी को जगह रे प्रिंटिंग मिस्टेक बा एरर तुमको लागिला, you can tell that in the comment box, right? The second problem, now evaluate the surface integral r dot n cap ds. Okay, and here s is the surface of upper hemisphere having radius small a with center at 0 0 0, and r is the position vector. Okay, so the surface of the hemisphere having your center at origin, that is 0 0 0, is actually normal to the position vector, that is r equal to, this should be small x. Okay, it is printing mistake achi. So x I cap plus y j cap plus z k cap, and at the surface we have r is equal to your radius, that is small a. Okay, therefore n cap, which is the unit normal vector to the surface, it is equal to r by r, that is vector r by magnitude r, which is vector r by small a, right? So the integrand r dot n cap will be now equal to r dot r by a, or it will be equal to r square by a. Now at the surface we have r equal to a, so that it will be a square by a, or simply a bahar को पड़े आसिला. Now एबे देखो double integral by surface integral रहीगला over ds, and in case of hemisphere this will be equal to 2 pi a square. मन रखो, in case of a sphere we have the surface area equal to 4 pi a square if it is having a radius small a. Now if it is a hemisphere, then this will be 4 pi a square by 2, so that it will be 2 pi a square, right? अच्छा, तापर एतिकी पाइला परे आमे याको पुट करि परिबा, so that final value हमरो जो r dot n cap ds रो surface integration यार value आसीगला 2 pi a cube, right? Next problem, एठी volume integral बाहर करे को कोइची 2x plus y रो, where v is the region which is bounded by the cylinder yaro equation dela z equal to 4 minus x square, and this proves x equal to 0, y equal to 0, y equal to 2 and z equal to 0. so आमे कौन करिबा ए जो गिवन सिलिंडर अछि जाकू इक्वेशन देछि z equal to 4 minus x square से एठी y रो तो ऑलरेडी लिमिट दे देछि 0 रु 2 हमकू x आउ z रो लिमिट दरकार. सो फर्स्ट हमें x रो लिमिट बार करि परिबा by knowing that it meets the x axis पई हमें जानि छु y equal to 0 आउ z equal to 0 हुए. सो एठी z equal to ए जगह रे 0 पुट करिबा. ओके z equal to 0 पुट कर देले 4 minus x square will be equal to 0 or x equal to 2. okay, that is it is meeting at the x axis at a point 2 0 0, right. तापरे it meets the z axis. For z axis we have x equal to 0, y equal to 0. okay, so एठी x equal to 0 पुट कर देले हमें z equal to 4 पाइबा. okay, this one. so point हमरा आसी गला 0 0 4. therefore the limits we have x limits आसी गला 0 to 2, y limits आसी गला 0 to 2. okay, this one. और z limit आसी गला एठी from 4 to 4 minus x square, right. एठी 4 minus x square कहीं की हैला because this one a equation दीची z रो जो equal to 4 minus x square, this will be the upper limit. और z equal to 4 जो हमें पाइला this one, this is the lower limit, right. ताले एबे हमें वॉल्यूम इंटीग्रल बाहर करि परिबा by using these limits of integration. so एठी देखो dv को भांगी देला dx dy dz रे आउ लिमिट अकॉर्डिंगली पुट हला x y आउ z पई. तापरे गोटे परे गोटे आमे इंटीग्रेशन बाहर करबा. प्रथमे z इंटीग्रेशन देन y इंटीग्रेशन तापरे x इंटीग्रेशन आ फाइनल वैल्यू तमे चेक करिवो इट शुड बी 80/3. ओके, सो इन दिस वे आमे लाइन सरफेस आउ वॉल्यूम इंटीग्रल्स विषय रे पढिला. यार ब्रीफ डिस्कशन एठी देखिला ए बही रे. ता छडा एठी देखो आउ गोटे बही रो मु नै छि एठी लाइन सरफेस आउ वॉल्यूम इंटीग्रल रो जोथरे कि आउ टिके डिटेल एक्सप्लेनेशन दी छि. प्रथमे देखो लाइन इंटीग्रल रे एठी खास करी a डॉट dr ऊपर मेंशन करी छि. ओके, किंतु फाइ dr किबा a क्रॉस dr ऊपर एठी खास किछि देइनी. से जहाँ भी हो तार केतरा प्रॉपर्टीज एठी देखो दिया ही छि. ता छोड़ा एठी वर्क डन विषय एक्सप्लेन कला केमती फोर्स रु आमे वर्क डन बाहर करि परिबा. ओके, या रिलेटेड एठी बहुत किछि प्रॉब्लम दी छि जोटा कि मु तम ऊपर टास्क देली फॉर योर सेल्फ स्टडी. ओके, गुडाए एठी देखो एग्जांपल अछि प्रॉब्लम्स. ओके, व्हिच आर वर्कआउट प्रॉब्लम्स. फिर भी जदि को जगह रे प्रिंटिंग मिस्टेक देन यू कैन टेल मी इन द कमेंट सेक्शन. ओके, सो ए जेते सब प्रॉब्लम अछि सबू जेते नकले भी दुई किंबा तीनटा प्रॉब्लम एटलीस्ट लाइन इंटीग्रल रु देन सरफेस इंटीग्रल रु तापरे वॉल्यूम इंटीग्रल रु जदि तमे करिवो ताले यू कैन गैदर एक्सपीरियंस. बिकॉज मैथमेटिकल प्रॉब्लम निजे न कसिले तमरो अभ्यास हेबनी. ओके, तापरे देखो एठी सरफेस इंटीग्रल यारो भी एक्सप्लेनेशन देला तापरे इवैल्यूएशन देला देन ता रिलेटेड एठी बहुत गुडाए प्रॉब्लम्स देछि. ओके, सो एथरु भी मु एडवाइस करिवि दुई तीनटा प्रॉब्लम तमे निजे करबा को चेष्टा करो. अगेन किछि जदि प्रिंटिंग मिस्टेक किबा को जगह रे भूल तुमको लागिला यू कैन टेल मी इन द कमेंट सेक्शन. एंड फाइनली हियर द वॉल्यूम इंटीग्रल. ओके, यार भी देखो एक्सप्लेनेशन किछिटा करिकी यार बहुत गुडाए प्रॉब्लम्स देछि. ओके, सो ये जते सब प्रॉब्लम गोटे गोटे करी जदि मु करेले बहुत टाइम नेबो. सो तमे निजे एथरु बछा बछा किछिटा प्रॉब्लम करबा को ट्राई करो. ओके, आ जदि को जगह रे किछि तमे से असुविधा होउछि यू कैन टेल मी इन द कमेंट सेक्शन. ओके, सो दिस इज ऑल अबाउट योर लाइन सरफेस एंड वॉल्यूम इंटीग्रल. ओके, थैंक यू.